Good morning, friends. Today we are going to discuss how the MCQs will be based on this particular unit number 4. See, you can see the adsorbent definition of the adsorbent is there. The substance on the surface of which adsorption occurs is known as adsorbent, adsorbate, like that. MCQ will be there. Then adsorption is a phenomenon in which a substance collects or concentrates on the surface of the another substance. This will be the another particular MCQ. Adsorbate, same way. Dot is the substance which get adsorbed on the surface of the another substance. Adsorbate, that you have to see that example will be there. Adsorbent includes silica gel, alumina, platinum, palladium. You have to remember. In the definition of the desorption, the process of removal of adsorbed substance from the surface of the adsorbent is called as The MCQs will be like that. Sorption, the process which makes it difficult to distinguish between the adsorption and absorption is known as is a phenomenon in which the substance is not only retained on the surface but passes through the surface and get distributed throughout the solids or liquid body. Answer will be the absorption. The amount of heat evolved per moles of the adsorb is called as heat of adsorption. Heat of adsorption is nothing but the heat evolved per mole of adsorbed. Here the example adsorption isotherm of the ammonia is here. In the adsorption of the ammonia on the charcoal, which will be the adsorbent and which will be the adsorbent, that may come for the identification in the MCQ purpose. Then different types of the adsorptions are there: physical adsorption and the chemical adsorption. Physical adsorption is also called as a physisorption or van der Waals adsorption. Chemical adsorption is called as a chemisorption or activated adsorption. That you have to remember because that may come in the exam. Okay, first of all, the definition. In the physical adsorption, is involved. Physical forces are involved, or so you can call it as van der Waals forces are also involved. In the chemical adsorption, is involved. Chemical forces. In physical adsorption, heat of adsorption is less than 40 kilojoule per mole. Or in chemical adsorption, heat of adsorption is varies in between to means 40 to 400 kilojoule per mole. The MCQs will be based on this difference also. How that the MCQs will come, that I am highlighting. Physical adsorption will takes place through multi-layer formation, whereas chemical adsorption is take place through monolayer formation. That MCQ may come. Okay. In physical adsorption, activation energy is In chemical adsorption, activation energy is Okay. Physical adsorption occurred at low temperature and high pressure. Okay. Same with the chemical adsorption is favored at higher temperature. Then adsorption isotherm, the MCQs will be there based on this particular. Adsorption isotherm shows the relation between the amount of substance adsorbed by an adsorbent and equilibrium pressure or concentration at constant temperature. This is called as the adsorption isotherm. Gives the relation between the amount of substance adsorbed by an adsorbent and the equilibrium pressure and the concentration at a constant temperature. That is called as the adsorption isotherm. Different types of the adsorption isotherms are there. Then Langmuir adsorption isotherm. That gives the theory of adsorption of the gases on the solid. It is also called as the unimolecular adsorption isotherm. The rate of adsorption of molecule is proportional to pressure of the gases at constant temperature will be the answer. Then when the rate of adsorption becomes equal to rate of desorption, the process attains equilibrium, which is called as adsorption equilibrium. Here that MCQ will be there. Okay. When the rate of adsorption becomes equal to the rate of desorption, the process attains equilibrium, which is called as adsorption equilibrium. Then another MCQs will be like that. The adsorption coefficient is given by K upon K dash. Then at low pressure, the term B into P becomes very small. The MCQs will be based on this part sometime. Then the bit equation, because of the restriction or say failure of the Langmuir adsorption isotherm, which only consider the monolayer formation, that monolayer formation is the drawback or limitation of this Langmuir adsorption isotherm. The Langmuir adsorption isotherm do not explain the multilayer formation. That's why the new law the new isotherm has been studied that by the Bronner, Emmett and Taylor, which shows the multilayer adsorption occurs at a side range of temperature and pressure. The first adsorption, first assumptions or say that particular thing is that adsorb layer may be multimolecular in thickness, and Langmuir adsorption isotherm, whatever the assumptions are there that are applicable to each layer. There is a dynamic equilibrium between the successive layers. The rate of the adsorption from first layer is equal to the rate of condensation of the preceding layer. The heat of adsorption is applicable to only first layer. After the first layer, heat of adsorption is equal to latent heat of condensation of the vapor. That bit equation is given by P upon V into P0 minus P is equal to 1 upon Vm into C plus C minus 1 upon Vm into C into Pa by P0. That may come for the MCQ purpose. Okay, the MCQs will be there based on this particular bit equation. Then bit equation is used to determination of the surface area of that particular adsorbent. Okay, that you have to remember how that we will do. Surface area of this particular adsorbent can be calculated by the formula S is equal to P0 Vx n sigma divided by RT0. That formula you have to remember. Sometime that formula may come for the MCQ purpose. This is the numerical based on this particular part. These are the that we can say the MCQs that may ask in the exam based on this particular part. Please keep on studying. Please read all this thing carefully. Next, what is a STP? standard temperature, pressure, that you have to remember. Okay, that formulas you have to remember because that may come for the MCQs purpose. Okay, here we will stop you. Thank you.